Remember how fun it was to be a kid? You didn't have to worry about rent or taxes or fixing that plumbing leak or just about anything except going to school. And some of us have avoided those grown-up things for just about as long as we could. Well, it's time for some tough love there, Peter Pan. A lot of us have been avoiding something unpleasant for a long time, and it's time to grow up and look it straight in the eye. Diagram. Yep, I'm talking about signal integrity. Hi, I'm Amelia Dalton, host of Chalk Talk. You know, sometimes we go along putting down our traces on our PCBs and grabbing some random connectors, and we just hope that we don't have any big problems. But with high-speed interfaces popping up just about everywhere these days, we need to come out of our playroom and get serious about signal integrity. Luckily, my guest, Matthew Burns from Samtec, is here to help us do just that. And it turns out it won't be so painful after all. Heck, being a grown-up can be fun, it turns out. And before we get started, don't forget to click that link. There you can find out more information about signal integrity solutions from Samtec. Hi, Matthew. Thank you so much for joining me today.
Thank you for allowing me to be here. Here at Samtec, we're really excited to talk about SI and what it means to you.
Okay, so the title we have is SI, Why Do I Care? And I have to confess that I already care a lot about signal integrity. But for those of my audience who may not be facing serious signal integrity issues yet, let's go through the basics.
Well, Amelia, you just stole the first line of the presentation. SI refers to signal integrity. So when we talk about signal integrity, what SI really does, that it ensures that a signal is transmitted from one point to another with sufficient quality to allow for effective communication. When we talk about signal integrity generically, that can apply to any system. What I mean is that in typical communication systems, there's a point A that acts as a transmitter and there's a point B that acts as a receiver. Communication systems can be over copper, they can be optical, they can be wireless. So signal integrity is of concern to any engineer that's designing a communication link. However, people are going to ask, why does Samtec get so involved with signal integrity? Well, when we come to channels that route over a PCB or over multiple PCBs, one of the components that's in the channel is a connector. So Samtec has become signal integrity experts because of the portfolio that we offer, and we also want to show why your listeners should care when it comes to selecting the right connector for their application.
Okay, so let's talk about the hazards our nice little signals encounter on their way from point A to point B.
In most systems today, point A to point B refers to a signal that gets transmitted from an IC over a connector to another IC on another PCB. The engineer's main concern is making sure that the signal looks the same when received as when it was transmitted. One of the key criteria in doing that is ensuring the proper connector selection for the engineer's application. Why is that of concern? Well, if we're running at slow data rates in the tens of megabits per second, signal integrity is something engineers don't usually have to worry about. But as data rates get higher, some of the physical limitations that the connector system has mechanically and electrically can affect the signal integrity of the signal as it passes through the mated connector set. So as data rates increase, engineers have to become more aware of the basics of signal integrity. Some of the basics of SI include four main technical terms. Most engineers may know this, but for those that don't, we'll review them in detail. Insertion loss, IL, or the minus 3 dB rating of a connector, measures the total loss incurred by a signal as it travels through the component, or in this case, the connector. Return loss refers to the amount of signal energy reflected back to the source as a result of the impedance mismatches in the overall transmission path. Crosstalk refers to the noise arising from the unwanted coupling of nearby signal lines. There are two types of crosstalk. Near-end crosstalk, or NEXT, N-E-X-T, refers to the level of crosstalk at the transmission end of the channel. Far-end crosstalk, or FEXT, refers to the level of crosstalk at the receive end of the channel. Lastly, we refer to the impedance of the channel, the cumulative reactance and resistance a circuit element presents in a circuit, and the differences that it causes in the system.
So if we look at the whole picture between two boards, how do we model this situation, and where does Samtec fit in?
That's a good question. When it comes to system modeling, most applications that we see today can be done so very simply. Our illustration shows that most engineers, when simulating their system, have to worry about three components: PCB trace, the Samtec mated connector, and the PCB trace on the other PCB. In most cases, or at standard data rates, this basic reference channel is more than sufficient for engineers to simulate not only the mated connector set, but also their channel. Samtec has used this system model for years when it comes to simulating our mated connector sets in response to the SI requests that we get from our customers.
All right, so how can we simulate this and see what's going on with our signal integrity?
As you know, Amelia, engineers love new toys, and we love to give our engineers the tools they need for the testing that they need to design our connectors into their systems. So one of the tools that we've developed and we've made available through our website is our simulator. Engineers interested in using this tool can access it via www.samtec.com/simulator. Simulator is a real-time high-speed performance tool that simulates Samtec interconnect systems, or mated connector pairs. Simulator integrates and blends data from models to project performance of your system. It looks at such SI parameters as insertion loss, return loss, near-end crosstalk, far-end crosstalk, and support eye patterns for high-speed mated connector sets and cable assembly pairs. So engineers that understand the four basic parameter types of signal integrity that we defined previously, you can actually see those results by using the simulator tool.
Okay, walk me through an example.
Would love to. So what simulator allows engineers to do is come into the tool, pick the mated connector set that they're interested in. Simulator supports 20 different families from Samtec. After the mated connector family has been picked, engineers can then pick the stack height of the mated connector pair, as well as the number of positions that their application requires. After they've done that, they can start to define not only the mated connector pair, but the system that the mated connector pair is a part of. Some of the parameters that they can choose in the simulator tool include the interconnect impedance, whether it's 50 ohm or 100 ohm. They can pick the trace type, the bit rate, which is really the data rate at gigabits per second. You can look at simulation types, signal to ground or differential. You can also look at trace lengths and slew rates of the signal being simulated. These parameters are easily chosen on the online tool. After the mated connector set have been chosen and the signal has been defined, engineers can then push simulate and the tool will give you the needed results.
So what kind of results do we get with that?
If we look at this next screen, you'll see that some of the outputs that simulator provides are insertion loss, return loss, and also crosstalk for the channel model that the engineer has defined. So simulator, which has been available for several years from Samtec, is a very easy to use, intuitive tool enabling engineers to simulate their mated connector pair in a quick and easy manner.
Now, what happens if I'm pushing higher data rates? Does this still work? It seems like the problem should be getting harder.
You're right, it does. Simulator is a great tool that we've had available for many years, and the signal integrity team that we have at Samtec that developed that tool continues to use it for several everyday applications. However, as you know, we're in a world where data rates continue to expand, it seems, at exponential rates. Why is that? Well, several macro trends are driving data rates in systems. System designs continue to become more complex, which continues to drive even more complex interconnect solutions, which continues to drive even more complex interconnect performance assessments or simulations. The graphic that we have here illustrates all of the components that Samtec has in their portfolio. The interconnect solutions that we offer and that our customers are designing in range from high-speed backplane applications to IC package and assembly, high-speed copper cable assemblies, high-speed optical cable assemblies, high-speed board-to-board applications for mezzanine-style interconnects, as well as front panel and edge card solutions. As data rates get to 28 gigabits per second and higher, modeling the system cannot be limited to just one mated connector pair. The entire system may have to be taken into account over several interconnect solutions. Additionally, the limitations of simulating just the mated connector pair are not sufficient at high speeds. Engineers are asking for more and more detail from Samtec as they route their signal from silicon to silicon. As a result, Samtec has put together a portfolio of signal integrity design solutions from silicon to silicon. Why are we doing this? More than the basics of SI are needed. Our engineering customers are faced with a growing number of design concerns that are affecting their system. One example is that many engineers have to conform to standards as outlined in the industry. These could be such things as Ethernet standards such as the IEEE 802.3BJ 100G base KR4 standard, or they may have to conform to such things as optical standards such as OIF CEI-28G, short range, medium range, or long range. Conforming to each of these standards require specific SI simulation needs. Engineers also have to be worried about channel performance data per user-defined transmit and receive assignments. Traditionally, engineers could choose their pinout on their connectors in any way they chose, but conformity to some of the standards or some of the standard interface connections, such as PCI Express, require routing signals to areas that may not be the best for optimized SI performance. Other parameters that engineers also have to worry about when designing at higher data rates include voltage bathtub curves, COM as a function of bit error rate, probability density I summary, and strategies for improved performance. An example of a mated connector pair that's running at high speeds is our C-Ray family of high-speed mezzanine connector set. The C-Ray family, when it was first conceived, was designed to run at gigabit rates in the teens. But due to requests from our customers, we simulated and we have applications running over C-Ray at up to 36 gigabits per second. So a lot of the testing that we've developed and the simulation that we've done internally, we know our customers need access to in an easy, accessible way.
So I assume this has a more complex model?
Correct. The days of using a simple model based on 3 parts or 3 components in the system quickly fade away as data rates get above 28 gigabit per second and migrate towards 56 gigabit per second or higher. The IEEE has done a good job of modeling a channel using their COM specification. COM refers to channel operating margin, and it serves as a reference channel for a lot of the simulations and tools that Samtec has made available. We illustrate what that channel looks like in the graphic here. You'll see, Amelia, that instead of having 3 components, that we actually have up to 9 parts of the system. We start with the transmitter. Next, we go to the package model of the transmitter itself, which is really a model of the IC assembly that the transmitter sits in. Next, we have the PCB trace that sits on the motherboard. We have the connector BOR, what that refers to as the breakout area of the connector set, how to route the signals as it comes out of the connector. You'll see at the very center, we have the Samtec mated connector pair, whether that's backplane or board to board or whatever the case may be. Next, we have the connector breakout region on the daughter card. We have the PCB trace on the daughter or component card, and then we have the receive package model, including the footprint, and the receiver model. So again, this is much more complex than what our simple channel used to be. However, by providing this more complex model, this is actually providing real-world simulation capabilities for Samtec and our customers to really simulate the system that their high-speed signals are routing through. Something else that we see here also is that you look at this graphic, that there's not just one model for each component of the reference channel. Samtec's model supports, for example, up to 5 different transmitters, and that can be due to various equalization schemes at various data rates. The package type for the ICs that we're simulating, there's several options there, and we can do the same on the receive IC and also the receive transceiver. As you can see, Amelia, this new reference channel environment is quickly becoming very complex. This may put a lot of fear into a lot of engineers that are listening, and the first time I saw it, I probably had that same fear. Samtec is providing tools that are easily accessible for our engineers and our customers.
Now, how do I analyze this? Do you have a solution?
Yes, we do. So that new reference channel model that we talked about serves as the basis for another online tool that Samtec has developed. Our new tool, which is based on the experience that we gained from Simulator, is called Channelizer. Channelizer is available from Samtec at samtec.com/channelizer. Channelizer is Samtec's online full channel simulation and analysis tool. Channelizer delivers high-speed serial channel performance data and optimization strategies within 24 hours. Leveraging user-defined system inputs, this easy-to-use tool provides the necessary data to reinforce channel confidence. Channelizer has several features that our engineering customers have asked for. It has the capability to model the channel defined by package model, connector selection, PCB material, trace type and length, and other system variables. It produces results for standards such as IEEE 802.3BJ, the OIF standards that we mentioned earlier for short range, mid-range, and long-range routes, and it also has the ability to define transceivers at varying equalization levels and data rates. Channelizer also generates individual receiver performance data per user-defined transmit and receive pair pin assignments. After an engineer defines their system using Channelizer, Within 24 hours, some of the detail that they'll get back from the tool via email includes a channel overview with strategies for improved signal integrity and performance, some of the SI characteristics designed for their system, including differential impedance, insertion loss, return loss, and crosstalk. Engineers will also get simulations for voltage bathtub curves for their system. COM is a function of BER, probability density I summary, and other details to improve the SI in their defined channel. Channelizer has been available from Samtec since March of 2016. Currently, we support both backplane applications and board-to-board applications. And throughout 2016 and going into 2017, engineers will also be able to simulate cable assembly solutions using Channelizer, as well as mated connector sets, which will be an extension of the capabilities that Simulator offers.
So, Matt, what if I need support with this?
Engineers like to do things by themselves, Amelia. We all know that. But in some instances, we all do need a helping hand to get us through our problem. If Simulator and Channelizer do not give engineers the results they need, Samtec provides in-house SI expertise for complex applications with live EE support available 24/7 worldwide. We have teams of experienced SI engineers located around the globe that our customers can contact via our website for support in any application. Some of the support that our SI team is able to provide include full channel analysis, high data rate simulations, application-specific design and development assistance, and advanced design support. The graphic here shows an eye diagram from a typical system that is not open completely. This customer was able to work with the in-house SI team at Samtec, and we were able to provide the necessary data and signal integrity optimization techniques to open up the eye completely, as shown in the bottom graphic. So this is proof positive that not only does Samtec offer the tools to enable engineers to simulate, analyze their system, but our in-house team of experienced SI engineers can support any SI problem that our customers may have.
All right, Matt, this was quite a lot to cover today. Can you recap your main points for me?
Hopefully we have shown, Amelia, that as data rates in our systems get higher and higher, understanding the basics of SI principles is necessary to ensure proper selection of the right connector for a specific application. If we're trying to run at 28 gigabits, we can't operate on a pin and header like we used to at lower data rates. We also hope that your listeners, Amelia, remember that Samtec offers both our simulator and our Channelizer tools, which provide online connector and full channel simulation and analysis. Both are easily accessible via the Samtec website. And in any event, if customers need SI support for any application, Samtec Signal Integrity Group can assist any customer with their SI challenges.
Well, I think that's all I have time for today. Thank you so much for joining me, Matthew.
Thanks, Amelia. We really appreciate the time to be able to talk to you about SI basics.
And before we go, you didn't forget to click that link, did you? There you can find out more information about signal integrity solutions from Samtec. For Chalk Talks, I'm Amelia Dalton from eejournal.com. For more Chalk Talks, head on over to the on-demand section of EE Journal or check out YouTube, keyword EE Journal.